Now, the argument goes as follows. If indeed the Earth was revolving around the Sun at a distance of 1 astronomical unit, then suppose that we have one star that is closer to us than a group of stars behind it. Then when we look at that star in July, it will appear to us to be to the left side of this cluster. So in July, we would see it here, right? It would appear to be closest to the end star here on the right. Then 6 months later, in January, when you view the same star against the background of more distant stars, then it would appear to be closer to this star that is at the left. So it would appear to be here, right? So basically, if indeed the Earth was revolving around the Sun, then we would see this apparent shift in the position of nearby stars relative to the background of more distant stars. And nothing like that was observed. So what is meant by a parallax is this apparent change in the position of an object, in this case a nearby star, due to the change in the location of the observer. And actually our vision is based on parallax. The two eyes, they actually don't give the same view. And you can see that if you close, say, your right eye, and then try to cover, say, me with the thumb, looking only through the left eye, right? So you don't see me then. But then you open the right eye and close the left, and all of a sudden you can see me, right? And the reason is that the two eyes have different viewing directions. So what happens is our brain processes the two images and gives us the perception of depth, right? Therefore, people who do not see in one eye, they don't have a perception of depth. And for them, for instance, it's difficult to play sports, because if you play any sport, say baseball or football or whatever, right? You need that perception of depth so that you know where you are in space relative to the ball, right? So our vision relies on this parallax effect, which is nothing else but the apparent change in the position of an object due to the change in the position of the observer, okay? So nothing like that was observed, argued Aristotle and others who supported his geocentric view. As a result, this idea that the Earth is revolving around the Sun cannot be correct, because if it was correct, then we would indeed see this apparent change in the position of the star relative to the background. Of course, what they did not realize at the time is that the stars are much, much farther away from us than what they thought. And if they are at a great distance, this angle here, so-called parallax angle, is very, very small. As the distance of a star increases, this triangle gets kind of skinnier. That is, this parallax angle gets smaller, and it's actually quite small. Even for the stars that are closest to us, it is less than 1 second of arc. Now, a degree, which is 360th of the full circle, is divided into smaller units. Into minutes of arc, 1 minute of arc is 1/60th of a degree, and 1 second of arc is 1/60th of a minute. That is, it is 1/3600 of a degree. To give you an idea as to how small that angle is, it's the angle at which you would see a quarter, a coin, at a distance of 5 kilometers from you. If you could see it, you can, right? It's a small angle. So even for the closest stars, that parallax angle P is very small, and it was actually observed for the first time in 1800s by German mathematician and astronomer Bessel. Okay? People realized earlier, with essentially Galileo, that indeed this heliocentric model is correct. Okay? But even then, we didn't have precise enough instruments to measure such a small angle. Okay? So the objection was correct, but was based on the wrong assumption that the stars are much closer to us than they really are. Okay, so to reproduce the diagram that I showed you, so here is the sun, and in heliocentric model, the Earth is revolving around the sun. So if I have here a nearby star and other stars in the background more distant than this one here, right? Then when the Earth is here, say in July, it will look to me that this star is closer to this one here. And then in December, it would appear that that same star is now closer to the one on the left, right? Is one astronomical, the base, and this angle here, P, it's called parallax angle. And if the distance d to the star is very large, the parallax angle becomes very small and hard to observe or detect. Okay, so the idea of Aristarchus was kind of rejected at the time, although he was completely right. Then people forgot about it. His writings were lost. And it was introduced reintroduced much later by Polish astronomer Copernicus in the 16th century, right? And he's often credited for being first to propose the heliocentric model. Historians believe that he was actually aware of the work done by Aristarchus much earlier, and he should really be credited for reintroducing and strongly advocating the heliocentric model, which at the time when he was doing that was actually very dangerous. You could lose your life by proposing theories that went against the teachings of the church, because by the 3rd century AD or so, and afterwards, increasingly more powerful Roman Catholic Church accepted the teachings of Aristotle as dogma, as something that is given. They argued that the Greeks came first, they discovered it all, there's no point in making new discoveries, new inquiries. All people need to do is just transcribe the works of Greek philosophers, mathematicians, and so on over and over again so that they don't get lost. Okay? So basically, the Aristotle model became frozen in time up until early 1500s.